Okay, so the second part of part 3 of the homework was also leading to some questions. So let me talk about it a little bit, although I think I'll be briefer here than I was for the other homework problem. So it says, suppose a space X is a union of a collection of open subsets, O sub A. So in other words, you have this collection of subsets that covers your whole space. So every point in your space is in one of these subsets at least. They can overlap some, but we know that they cover the whole space. Show that a map F from X to Y is continuous if its restriction to each subspace O sub A is continuous. Now there's a couple of things here. Any open set of a space, or any set of a space, can be considered a subspace. So here we're talking about open subsets, and here we're talking about subspaces, but of course any subset can be a subspace. So there's no contradiction there. And the other thing that might be continuous here is what I mean by restriction. So so we have a map that maps from X to Y for the whole space, and given some open set in X, we already know, so we can consider F applied to just that open set. Right? We've already talked about that. That's just a set map. As a set in Y, right? Now what I mean by F restricted to, and this is the notation I sometimes use, to the open set, is just well, how do I want to say this? What I mean by F restricted to the open set is we can is just F, but only considered a map on O. In other words, since O, this open set O, and maybe I should say O sub A here for all of these, so I want to pick out a particular open set. What we mean by restricting the map to O is that since the map F applies to the whole space, it certainly applies to O, and we can consider it just as a map from O sub A into Y, i.e. F restricted to O sub A maps O sub A into Y. For example, f of x equals x squared is a map from R into R, right? It's a map from real numbers into real numbers. Let's say consider the subspace 0, 1, then f restricted to 0, 1 is just a map from 0, 1 into R that does the same thing. F of x goes to x squared for all x in 0, 1. In other words, if you have a map from the whole space to another space, you can certainly consider that a map from any subspace to another space. So I hope that clears up at least one question that was asked about that. And then the question is, if we can sort of construct all of x from open subsets, and we can show that there's a function that's continuous on each of those open subsets, that it's continuous on the whole space. So here's another example. So let's say, notice the sets, let's say, -2 to 2, -1 to 3, 0 to 4, and then continuing this pattern in each direction, cover all of R, right? An infinite family of sets. They're all of length 4 units long, open sets 4 units long basically. And there's one centered at each integer, so they cover the whole space. There's no gaps. Cover all of R. And let's say if f is continuous for each of these, is it continuous on all of R? And the answer happens to be yes. And if you want a hint, you really only have to make sure that the maps match up on the intersections. And if you need more of a hint than that, I'd be happy to provide it. I'm not trying to be obscure, but I think you can get